Hello everyone, and welcome back to the channel. What you're about to see might completely rewrite everything we thought we knew about comets. Fresh images from yesterday have revealed something so bizarre about Comet 3I Atlas that scientists are genuinely baffled. For weeks, every expert was convinced this thing was tearing itself apart. The math was clear, the evidence was overwhelming, and fragmentation seemed like the only possible answer. But these new observations just threw all of that out the window, and honestly, what we're looking at now is way more disturbing than a simple breakup. Before we dive deeper into this story, make sure you hit subscribe and turn on the bell so you don't miss the next video. Alright, back to it. So let me walk you through why this situation got so intense in the first place. Back on November 9th, astronomers captured images that showed something absolutely wild. This comet had developed massive tails stretching out millions of kilometers into space. Now here's where things get weird. Gas from comets moves pretty slowly by space standards, only about 1,500 kilometers per hour. For those tails to extend millions of kilometers at that crawling speed, the comet would need to be constantly ejecting material for months on end, but images taken just days before showed absolutely nothing. No tail whatsoever. The comet looked completely inactive. Then suddenly, boom, these enormous structures appear out of nowhere. The physics behind this didn't add up from the start. Scientists ran the calculations and discovered the comet would need roughly 1,600 square kilometers of surface area actively absorbing sunlight to produce what they were seeing. That's equivalent to a sphere, about 23 kilometers across. But when Hubble measured 3I Atlas, it came back at only 5.6 kilometers in diameter. The object needed to be 4 times bigger than it actually was to explain the observations. That's not a small discrepancy. That's a massive problem. Then the numbers got even more disturbing. When researchers calculated how much material these tails were carrying away from the comet, the estimates showed 3I Atlas was losing approximately 50 billion tons of mass every single month. Remember, the entire object is estimated to weigh only about 33 billion tons. You see the problem here? This thing was apparently losing more mass than it physically possessed. Scientists had seen this kind of impossible situation before though. Comet Shoemaker Levy 9 broke apart back in 1992, and it released way more material than anyone thought the original comet contained. But that mystery solved itself pretty quickly once they realized it had shattered into 21 separate fragments. When a comet breaks up, all those pieces suddenly have way more combined surface area exposed to the sun's heat. More surface means more ice turning into gas, which creates bigger and brighter jets and tails. The math finally worked. So when astronomers spotted 7 distinct jets shooting out from 3I Atlas on November 8th, followed by those multi-million kilometer tails the next day, everyone drew the obvious conclusion. This comet had to have fragmented. There was simply no other way a single solid object could be losing more mass than it weighed. The science was settled. The case was closed. Fragmentation was the only logical explanation for what they were witnessing, except it turns out they were completely wrong. On November 11th, 2 astronomers named David Jewett and Jane Liu aimed a powerful telescope in the Canary Islands directly at 3I Atlas. When they published their findings, they gave it the most straightforward title possible: 3I Atlas, still single, not broken apart, not fragmenting, not scattering debris across space, still one solid piece. But here's what makes their work so important. They didn't just glance at it and say, "Yep, looks intact to me." These researchers conducted an incredibly detailed analysis using every technique available. At the time of observation, the comet was sitting about 1.5 astronomical units from the sun, roughly 214 million kilometers out. It was a little over 2 astronomical units from Earth, about 320 million kilometers away. They examined a region surrounding the comet that spanned roughly 500,000 kilometers across. That's an enormous search area, specifically designed to catch any signs of breakup or scattered fragments. What they discovered was one single, bright nucleus at the center. That's the solid core of the comet. Surrounding it was an active, glowing cloud of gas and dust called the coma, which had this complex, structured shape. They observed 2 tails extending in opposite directions, exactly like the previous images had shown. One tail pointed almost directly toward the sun, measured at about 106 degrees, while the sun was positioned at 115 degrees. only a 9-degree difference. This is what's called an anti-tail, and while it's rare, it's not impossible. The other tail stretched away from the sun in the normal expected direction at about 301 degrees. They used multiple image processing techniques specifically designed to detect fragments. They stretched the brightness levels. They created contour maps. They applied false color filters. They analyzed the image in concentric rings, moving outward from the center. Every single method was chosen to reveal even the smallest pieces, if they existed anywhere in that region. And their report explicitly stated that the entire imaged area showed absolutely no hint of fragmentation whatsoever. Think about what this means. If the math suggested 3-eye atlas should have broken into 16 pieces, those fragments would be spreading outward. They'd be visible as separate bright spots. They'd leave distinct trails behind them as they moved. But the images revealed none of that. Zero evidence. This wasn't just a casual observation either. Professional astronomers carefully examined a massive region of space around this comet using multiple sophisticated analysis methods and found nothing. No breakup, no fragments, no debris field. And remember the timeline here. This object had just survived the most brutal part of its entire journey. It passed its closest point to the sun on October 29th. It got blasted with extreme temperatures. Everyone expected the thermal stress alone to crack it into pieces. The immense pressure from all that gas violently shooting outward should have blown it apart. Yet 2 weeks later, it's still one solid object, actively producing enormous jets, firing in multiple directions. If this thing really is natural, and honestly I think it is, then scientists are facing a serious problem. They need to explain how this is physically possible. So here's what I think might be happening. We know 3-eye atlas is ancient, probably billions of years older than our entire solar system. Could be 7 billion years old, maybe 10 billion, we're not entirely sure. For all those billions of years, this comet was drifting through the emptiness of interstellar space, getting constantly bombarded by cosmic rays. These are incredibly high-energy particles that slam into objects and fundamentally alter their chemistry. Imagine radiation slowly cooking the outer surface over billions of years. The James Webb Space Telescope actually found something fascinating that supports this idea. 3-eye atlas has approximately 8 times more carbon dioxide compared to water than typical comets. That's a huge difference from the normal ratio. This could be evidence that cosmic rays spent billions of years converting carbon monoxide on the surface into carbon dioxide. Those same cosmic rays might have created some kind of bizarre crusty layer covering the surface. This crust could cause the ice underneath to sublimate in really strange ways we've never observed before. Maybe it's creating internal channels or pockets that give the comet way more effective surface area than what we can actually see from the outside. Another possibility is that we're calculating the required surface area completely wrong. Maybe sublimation can happen much faster than current models predict under certain specific conditions. Maybe these jets aren't actually carrying as much mass as the calculations suggest. That 50 billion tons per month figure came from analyzing how large and bright the tails appear, then working backwards to estimate how much material must be present. But what if the tails are just incredibly efficient at scattering sunlight? What if they look way bigger in terms of mass than they actually are? If the real mass loss is closer to 5 billion tons monthly instead of 50 billion, suddenly the numbers start working. That's still extreme output for an object this size, but at least it becomes physically possible. The problem with this theory is that scientists have been calculating comet mass loss using these methods for decades. The technique works reliably. So if it's suddenly completely wrong for 3-eye atlas specifically, we need to understand why this comet is so different.